Anybody?
You just worked some more of those problems from the homework.
Okay, so that's all I did. I didn't, okay. So let me pull up the whiteboard. Where is the whiteboard? Must be on this screen. Give me a second. I gotta pull, where's the whiteboard? Did she take the whiteboard off? Oh, my Lord. It's not on here. Okay. People wonder why I teach at home. Whiteboard's not on here. Okay, then I'll have to use the slides, which I cannot stand to use. Shoot. Just give me a second, I'm sorry. They give me a hard time about teaching from home, but then when I teach from here, this is what happens. Give me a second, guys at home. I'm pulling this stuff up. I don't have a whiteboard, so I'm gonna have to do this. Okay, now, let me get there we go. And we're already through 5.1, so let me go down. And of course, I don't have them. That's toward the end of 5.1. Okay, there's one of the questions I was going to ask right here. So we'll start right here. The difference between there's two parts in 5.1. There is the, oh my God. Hold on a second. Primary monitor. There. I'm sorry, there we go. There is two questions I'm going to ask you as far as mathematics goes with 4.1, 5.1 material. One will be, what is the probability of rolling a 6 on a die? What is the probability of rolling a 2 on a die? What is the probability of picking a king out of a deck of cards? All right, those are single events. Everybody with me? And one of these. What is the probability of, and I wish I could draw it, but I don't have a whiteboard, so there's no need to do it. What is the probability of a 7 with a pair of dice? And now you're going to have a sample space. Now, did I send y'all these? Did I send y'all the pictures of the sample spaces? Yes or no? Probably not. So what I'll do right now, I don't have my computer, so I can't. So forget it. I'll just try to do it when I remember to go home. These are sample spaces. Sample spaces is a group of events. Write that down. Sample spaces are a group of events that can possibly happen. So these are the possible events that could happen. So if you got 6 sides on a die and you got 2 die or a pair of dice, then that's 6 to the second power. 6 to the second power is what? So you got 36 different events. You had 3 die, it would be 6 to the third power. So there it is. So how many 7s can I get? Well, there's 6 7s right there. See, now let's see the pattern. All of those equal 7. So what would the probability of rolling a 7 with a pair of dice be? Well, you know your denominator is 36.
1 out of 6.
Huh?
1
out of 6 or 6 out of 36 reduced down to 1 out of 6. So write down probability parentheses 7 on a pair of dice is equal to 6 out of 36 equals 1/6. Now, should you take this and put it on an index card? Yes. Only 2 of you will, but I'll send it to you if I remember to do it this afternoon. Let me show you where to find these and you can make your own, or I could do it for you right quick because I know some of y'all aren't going to do it. So let me go and find them for you. And there's 2 or 3 others that I'll also pull up for y'all. And if I had access to my other, okay, I could do that. Hold on, let me try that. Okay, I'm going to go to your sister class and go to files, where half of y'all don't even know exist after we showed it to you the first week of class, and sample spaces. And I should be able to download if this computer don't blow up. Where's the download? There it is. Now let me see if it's on this computer and I can send it to you. You're welcome. Hold on. So let me go back to that. Why is this thing off-centered? There. Close. This computer is all messed up. I'm sorry. It's working. What the? It's working, but it's all discombobulated because it's not configured the way the other computer was. So here's y'all, and I'm going to go to files and I'm going to upload, and I have no idea where it put it, probably on downloads. Sample space. All right, somebody at home, let me know if you see it pop up in the files, or somebody with a computer in here. Please, it's called sample space. Please let me know. Yeah, there it is right there. So, all right, now I'm going to show you that document. Here is 3 children. That is a very popular question on the test. I'm going to ask you a question right now. I want you to write it down because half of you are going to miss it. Probability of at least 1 girl. Probability, parentheses, at least 1 girl. Somebody tell me that probability. What is it?
1/4.
Nope.
3 out of 8.
Nope. I heard somebody say it.
It's 7 out of 8.
7 out of 8 is the correct answer. Half of you got it wrong. Why? Because at least means what? There's at least 1 girl. So could there be 2 girls? Could there be 3 girls? That's why people miss probability questions. They miss them because they don't what the question? They don't read it. Now, all of you know how to read. That's not what I'm saying. I'm saying that you look at the question and instead of seeing at least one, you see one. And that's why some of y'all said, you know, at least one would be 3/8. That's why some of you said that. It's not at least one. That's one. So make sure you make that distinction. This is a very popular question on my test, and it's a very popular question on standardized tests. So you make sure you write this one down. Of course, you don't have to, but you have to print it out, and that causes, you know, you have to press a button. So some of y'all might not be able to do that. Here's 4 children. That's another one that's on standardized tests. Now, why am I telling you to print this out? Do you want to configure this and create this every time you have a question on it? I don't think so, because you'll leave half of them out. So that's why I made this document for you. And there is your dice. So what I tell students to do is take these 2 or 3 pictures, cut them out physically, and put them on an index card. Okay, for the 2 or 3 that's going to do it. And for the test, you'll have it there with you when you answer the 3 or 4 questions that I'm going to put on the test from sample spaces that some of y'all will miss because you're not going to do it. Okay, so what is the probability of an 11? Well, here's your 11s right here. 2 out of what? 36, and reduce and simplify according to directions. What I mean by that is make sure you read the directions. It may say simplified fraction, or it may say decimal rounded to the 100th or the 1000th. You got to read the directions. I'm going to tell you that the probability of 11 is 2 over 36. You as students automatically know that you have to reduce that fraction, or you have to put it in a decimal form according to the directions. I'm not going to do that. I mean, y'all should know how to do that. All right, so that concludes 5.1. We already talked about the first part of 5.1 before the whole residential or residual debacle, okay, and the camera debacle. So that is the second part of 5.2. Make sure you know a single event, probability of a queen out of a deck of cards. That's a single event. And a sample space event, which would be more than one event happening. Another example is 2 children. Now, I didn't put that on there because I couldn't find one. I'm not saying when I was in the middle of class when I did that, and I just saved it to the other classes. So I didn't look for 2. There's probably one on Google, just hit images. And you want to look up sample space 2 children, sample space 3 children, sample space 4 children, sample space pair of dice. What about 2 coins? 2 coins would coincide with 2 what? Children. Heads, tails, male, female. See what I'm saying? So you could use both of them, you put them side by side. What is the probability of at least 1 boy? Well, that'd be 3 out of what? 3 out of 4. At least 1 boy. What is the probability of 1 boy? That'd be 2 out of 4. So hopefully you start to understand the sample space. And if you use this and put it on an index card to make life a whole lot easier for you, for the 2 people that's going to do it. Okay? Now let's go back to, and let's go to 5.3. All right, if we ever get to 5.3, I'm trying to get there, or 5.2. What is 5.2? Well, 5.2 is the additive rule. Write that down, additive rule. As soon as I get there. And there it is, 5.2, the addition rule. I call it the additive rule, the addition rule. Now you're going to have to write some of this down because I don't have a whiteboard. Okay. Write this in red because this is the main rule that you have to remember about the additive law. Always subtract the overlap. Always subtract the overlap. That is the main rule with the additive law. Now, another rule, always try to put it in table form. Always try to put it in table form. Now, there is no way I can show you how to do it like I did the other two classes. So what we're going to do today, since the computer is still not right, but it's working, but it's not right, is I'm going to just go over some of this stuff. And then Friday, we will go over 5.2 and 5.3 when I get the whiteboard up. If I get the whiteboard up, if somebody puts it up there. Okay? So the two rules for the additive law is one, make sure you subtract the overlap, which I'll show you when I have a whiteboard. And two, make sure you have it in a table form if possible. So that means you have to read the question and see if you can put it in a table form, which I can't show you yet. Okay? What is the, and I want you to write down 5.3, the multiplicative rule. The multiplicative rule, the two rules that you have to remember with the multiplicative rule are without replacement and with replacement. Without replacement and with replacement. Without replacement means that you pick a marble out of a bag, you write down the color of the marble, and you put the marble in your pocket. That's called without replacement. That is called dependent. Or I put in parentheses, dependent. Because the book and the homework is going to ask you, is this event dependent or independent? Dependent means without replacement. You pick a marble out of a bag, you put it in your pocket. So I hope everybody's writing, please. And not texting on your phones because that's very annoying. Okay? And it disrupts my train of thought. I don't know what I was talking about. Okay. The second one is called independent, and that is with replacement. So you pick a marble out of a bag, you write down the color, and you put it back in the bag. That is called independent. Another way to remember the two, dependent affects future outcomes. I know it is boring. Affects future outcomes. Because if you take a marble out of the bag and you don't put it back in after you record it, what does that do to the mathematics? It checks the mathematics. You don't have 10 marbles in the bag anymore. You got 9 marbles. So remember, dependent affects future outcomes. Independent does not. If you put the marble back in the bag, it does not affect the mathematics. Now, the key words, there's 2 key words. Any of you probability people know these 2 words for additive and multiplicative laws. Anybody? Okay, the word for the additive law, and you put it in quotation marks and highlight it, is or. O-R, or. What is the probability of picking a king or a queen out of a deck of cards? The question we'll have at the end, what is the probability of blank or blank? If you see that or, that means additive law. So anybody know the word for multiplicative law? And. Good job. And. So that's 5.1 and 5.2. The sad thing is, I really can't do anything because I can't draw. And I don't have any pens, and I ain't gonna draw with that pen that's been open for the last 2 weeks, and I'm not gonna try to draw on that that nice board because it'll mess it up. So y'all be patient. I'm sorry. I can only do what my equipment will let me do. So I'm gonna keep on going. And they call it disjoint and joint in the additive law. Two events are disjoint if they have no overlap. Write that down. Disjoint means no overlap. Another name for disjoint, because that's not sophisticated enough, hold your pinky up, mutually exclusive. I swear, I believe there was a mathematician millions of years ago, thousands of years, that couldn't hack it as a mathematician and just started making up stuff and called it statistics. Because some of this stuff is just so, what's wrong with disjoint? Why can't you use disjoint? No, that's not sophisticated enough. You got to call it mutually exclusive. A bar chart is not sophisticated enough. You got to call it a histogram. I'm like, really? But anyway, y'all think that's only in academia, but you wait till you get out in the real world. It's the same. People go into debt, try to keep up with their neighbor. All right. Where is my, there it is. Is that it? No. There it is. Where is it? There we go. There, thank you. So these two right here are disjoint. I don't use Venn diagrams to show, I use a table and I draw a line with a highlighter and I draw another line, and if they overlap, if the highlighters overlap, it's jointed or inclusive, whatever you want to call it. All right. They use Venn diagrams. These two are disjoint. There's no overlap. See, you've got set E with 0, 1, and 2. You got set F with 8 and 9. There's nothing in common. Do you remember in algebra, what did you call two sets that overlapped? What was that? Was that an intersection or a union? Intersection. Think of the intersection at Standards Road here. That asphalt that's in that intersection, does it belong to Michelin Boulevard or Standards Road? Both. It's overlap. Okay? That's an intersection, is an overlap of asphalt. What is a union? Just what makes up the whole bit. Remember the Union, State of the Union? The Union after, the nation after the war between the states became what? The Union again. The Union, meaning there wasn't any overlap, there was just people mashed together. The Union would be 0, 1, 2, 8, 9. So union means disjoint, means mutually exclusive. So the things that you learned back in algebra wasn't sophisticated enough. So a union means disjoint, means mutually exclusive. An intersection means overlap or jointed, and I guess you'd call it mutually inclusive. I don't know what they're going to call it. They'll probably change it next semester. And you would just add those up there and there. I don't like to do this. I'm not going to show that to you. We're going to keep on going. I don't want to confuse you with the Venn diagrams. I want to show you how I do it, and we'll go from there. So this is disjoint. You add the probability of E and the probability of F, and you add them together. There's no overlap. Versus an overlap, which should be two Venn diagrams overlapping. Let's see what they call right here. Let's see. Those are not overlapping. Well, are they ever going to give us an overlap? Please don't use the cards for an overlap. There, finally. Here is an example of overlap. And of course, they didn't give you any words, so maybe it's right here. Nope, I guess you just make up your own words for overlap. So we called it what? An intersection, overlap, in common, mutually inclusive. Anyway, you got these numbers here, and 1 and 3. So what's in the green? Well, see, the way they've got it, it's confusing. 1 and 3 belongs to one of the sets, and they didn't include it. So this is,
It was mutually exclusive, it would belong to both, right? That's why I had-
yeah, see, that's what it's supposed to say. It's supposed to say 5, 7, 9, and then 1 and 3, and then the purple one's supposed to say 1, 3, 0, 2, 4. Now, what are in common? The 1 and 3. So you would subtract the 1 and 3. You would write down 5 plus 7 plus 9 plus 1 plus 3 plus 1 plus 3 plus 0 plus 2 plus 4, and then you would minus the 1 and the 3 because that's an overlap. But the way they've got it here, it's not. I don't want to spend too much time on this because that's going to confuse you. And here is the overlap rule, meaning that you always subtract the overlap. Now I'm kind of iffy right here because I don't teach it this way. I don't. I teach it with a table, and I'm sorry that I'll go over it with you Friday. But we're going to keep on going, and maybe I can find an example in these slides to help you out. But right now I don't see anything. Here's, okay, the probability of a king or a diamond. Okay, so I would go back up to that, a king or a diamond. Let's go back up to that slide. There we go. Now this is a table. A king is right here. Everybody got it? So you would draw a vertical highlighter line through the kings. Everybody got that? So that's 4 out of what? 52. And then, how many diamonds do you have? 13 out of what? 52. Is there an overlap? Yes, 1 out of 52. Everybody with me? So that's why I don't use the Venn diagrams. Venn diagrams confuse people. Here's a king, and you put a red highlighter line through that, and then a yellow highlighter line through the diamonds, and then that's going to be 4 over 52 plus 13 over 52 minus what? 1 over 52. See, it's a whole lot easier when you do it that way. So let's see what they got. They probably got disjointed function inverted or something. Where is it? Is it back up? Right here? Go up? I'm trying to find it. Is this it? Okay. And the king, where's the king? Well, I lost the king. I'm sorry, y'all. This is just, I thought it was around the overlap. Was it not around the overlap? There. 4 over 52 plus 13 over 52 minus 1 over 52. So I'm giving you the directions. I'm just not showing you how to do it. I'm sorry. Please make sure you distinguish on your evaluations. It wasn't my fault about this week because it wasn't. I got an email. Did you take this from home last week? I said, yes. Somebody evidently called her and told her. You're supposed to be face to face. Well, when the equipment don't work, I teach at home. And let's move on down. I want to talk about the complement. There we go. Somebody give me a definition of a complement.
That's in common.
Say again?
Something that's in common.
Something that's in common. Yep, that's right. You could say that, but it's not 100% right. But that's you're on the right track.
The opposite.
The opposite. That's not correct, but it's on the right track. It's what makes up the whole. Write that down. What makes up the whole? In other words, a true-false question. The question is in common, right? And true and false is opposite, right? So the two of y'all answered the question semi-correctly, but the actual definition of a complement is what makes up the whole. Let me ask you, everybody knows, what are those things you carry around in your pocket? So you carry ones, you carry fives, you carry tens. It's called money, currency, right? A dollar is one whole unit. Does everybody agree with me? So if I give you 35 cents out of that dollar, what's the complement? If I give you 35 cents out of a dollar, what's left over?
65.
That's the complement. The complement to 35 cents is 65 cents. Complement of true is false. The complement of guilty technically is not guilty. But we could argue that because is OJ innocent?
No.
No. Okay, so I could spend a whole class talking about guilty, not guilty, and innocent, but we're not going to do that. But I'm going to say the complement of guilty is not guilty. Complement of 0 is 1. The complement of black is white. The complement, and y'all get it? In other words, what makes up the whole? Now let's say I have 500 students and 30 of them are sick. Then how many are not sick? 470. So the complement to the 30 to sick is 470, which I think one of y'all said the opposite. Okay, so you see how the two answers, kind of come together. This is a test question. It is also a standardized test question. The complement is always the other side. Okay, so if I say there's 500 students, I got 500 students that I teach every semester, and 30 of them are sick, then that means the complement becomes what? Not sick. You get it? And the 470 is what makes up the whole of 500. Each complement has to make up the whole. You put them together, it makes up the whole. Does that make sense? Because that is a test question. So if I ask you a while ago, what is the complement of picking a king or a diamond? And y'all came up with what? 12, let's see, what was it? 13 plus 4 minus 1, 13 plus 4, 16 over 32. Well, what would be the complement of that? 52. Would be the 16, what's 16 from 52? I think, 26 or 36, something like that. So that would be the complement. Capiche? All right, let me ask you another one. This is so hard teaching without writing. If you have 4 kings out of a deck of cards, the probability of kings is 4 out of 52. So what is the probability of not a king? Y'all articulate. Yeah, 48. 48 out of 52. You got it? All right. What is the probability of rolling a 6 on a die? 1 out of 6. What's the probability of not rolling a 6 on a die? There you go. You got it. So you both were right. What's in common? What's opposite? But it's really what makes up the what? The whole. Okay. What's the complement of ketchup? Mustard. Some people say complement of mustard is mayonnaise. Okay. But, what's the complement of yin? Yang. Balance. All right. This is so awkward. There it is, complement of event. Let's see what they call it. Let's see what they say right here. No. The complement of E, denoted E to the C, is all outcomes in the sample space that are not outcomes in the event. More power to you. I have never seen this before. E to the C, I have never seen that before in all my mathematical experiences with statistics. I have seen E with a line over it. Write that down. E with a line over it. I've seen E with a X through it or a slash through it. I have never seen E to the C. So that must be something that somebody said was more sophisticated than a line on top of E. That is a test question. The test question will ask you, I'm going to write that, you want to write this one down? The probability of E, P parentheses of E, is 0.75. What is E to the C power? It'd be what? 0.25, because probability goes from 0 to what? 1. So if you have a decimal of 0.75, what is the complement? 0.25. So that is a test question that somebody will miss after I've done told you.
So, is it on the test, is it going to be EC or is it going to be?
It'll say P of E, parentheses, is equal to 0.75.
Okay.
What is E to the C?
It's not going to be E bar.
No, because that's where this is the first time I've seen it in this book.
We need to make a mental note.
Yeah, E to the C, yes. Don't worry, it'll probably pop up on the pretest. If not, I'll find it and show it to you. It'll be on your homework. And let me see if they got a good example on here. This is the way they show it with a Venn diagram. The probability of E is green. What's outside of E is the complement. I don't like that one. But according to the National Gambling Impact Study, 52% of Americans have played the lottery. So who has not played the lottery? That's your complement. Usually, the complement has a naught in front of it, or a slash through it, or an X through it, because it's what makes up the whole. The whole is the 1, because the probability goes from 0 to 1. I know I'm saying things over and over, but the reason I have to is because students sometimes need that. Now, you can have a complement as a percentage, and you can have a complement as a quantity. Like I gave you the example, I have 500 students, 30 of them are sick. How many are not sick? 470. So you can have it as a percentage, a decimal, or a quantity, or a characteristic. Like what? How many people in the group are brunette? Let's say there's 15 people in here. 5 are brunette. How many are not brunette? There you go. So you can have it as a characteristic. Blonde, not blonde. Brunette, not brunette. And this is the multiplicative rule. And I know I've only got 10 minutes, but I want to show you the important parts of the. Let me ask you something. How many of you have taken a probability and statistics in high school? Okay, who remembers a good bit? Okay, did y'all do this in probability and statistics? Okay, good. So about half the class raised their hand. The rest of y'all are just SOL. Okay, because they're gonna make an A and you're not. All right, independent. We talked about independent and dependent. We talked about that. I want to get to the examples since I can't. Let me see if I can get disjoint. We talked about that. Yeah, I think we're going to stop there. Okay. The reason we're going to stop there is because I'm not going to confuse you with Venn diagrams, and I sure as heck ain't going to confuse you with doing. I just do things different from the slides. Okay. So we're going to stop there, and I hope y'all give me an A for salvaging the class since we didn't have a whiteboard. So I will email IT. No, I'm just, give me an A for effort. Okay, please. I've had a rough week. The microphone didn't work, called it in. They didn't fix it on Wednesday. They came in Friday right before class. And if I'd have showed up for class, you know what would have happened? It wouldn't have worked. But since I didn't show up for class and I called from home, it worked. That's the way things work, okay? It's called catch-22. Have y'all ever heard of that before? Damned if you do, damned if you don't. All right, so what I'm going to do now is I'm going to shut down the recorder. Somebody's got a question. Okay, I can't find the join button. Oh, okay. Okay, it came up. Okay. All right, so let's see how many people we got in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And we've got 17, 18, 19, 20, 21, 22, 23. That's good enough for me. I'll just say everybody's here today. All right, y'all get out of here. People at home, I will try to get everything straightened out, and hopefully we'll have a whiteboard Monday, okay? I mean, for what? Friday. Homework, just work on 4.1, 4.2, 5.1. You can dabble in 5.2 and 5.3 if you want to, but I wouldn't suggest it because I haven't fully presented it yet. Okay? Thank you.